I will start with a story, a real story that happened to me. 2 weeks ago, I had some pain on my left shoulder, so I decided to book an appointment to the doctor. So the next day, I came to the doctor's office, and once I came, I saw on the monitor that I'm the next one in line, so I waited near his door. Meanwhile, I could hear that the doctor is doing conversation with another patient, and he told him, I could hear at least several of the sentences. He repeated over and over again the sentences that I need some medicine, I know that you need it, I cannot give it to you. Unfortunately, I cannot help you. I know that you are asking over and over it, but I cannot. And probably after a few minutes, he hung up the phone. So it was my turn to enter to the room, so I entered to the room, to the doctor's office, and asked him, do I need to leave the door open, or should I close it up after me? So he told me, no, leave it open. He was a little bit red in his face, so I could at least a little bit understand where things are going. And then he told me, okay, what is the problem? So I explained it to him, and he told me, no, you don't have nothing. You probably want some day off from work or something like that. So here's the door, bye. I told him, are you sure? Because I'm in pain. I need to be examined, maybe to take, I don't know, additional test or something like that. And he told me, no. And he called and shouted out to the next person in line to get into the room. So eventually I understood that, yeah, it's a real story, by the way, yeah. I hope no, but at least he's still working in the clinic near my home, so I will not see him again. But the fact is that eventually I understood that the patient before me asked for a specific request to get the relevant medicine he needed, to get a specific response for the examination that he needed, and so on. And he didn't get it, so there was kind of a stressful interaction between the patient and the doctor. But although the patient before me suffered from it, I also suffered from it. Now, take this specific example and think what can be if we could detect those stressful interactions. In our example, if we could, let's say, once the doctor finished with the patient before me, tell him, wait, don't see another patient, go on to a coffee break. I think I will be glad of that, no? So, hello all. My name is Tal. I'm a data scientist at NICE here. And I want to present to you one of our work, audio stress detection. So we ask ourselves these kind of questions. How to detect that a person is under stress during an interaction. So I want to show to you several of the challenges that we faced with and the solution that we used, and to present to you our work. So first of all, lack of data. I don't know how many of you are familiar with this kind of work, but in stress or no stress, there isn't any public label data. Only emotion detection data is available. So we used emotion detection data. But again, as you probably know, there are lots of emotion, and we are looking on a binary classification problem. Which kind of emotion should we use? So eventually, we use kind of an extremely positive emotion versus extremely negative emotion, and created us a binary classification task. But then we faced with another question, imbalanced data. First of all of us as human beings are not expressing the entire emotion that we have. Some of us are expressing specific emotions, some of us are not expressing emotion at all. But it means that we don't have enough samples of each emotion that related to the relevant groups. So what we did, in a simple word, we tried to find the most important features on the less frequent class. And eventually, we stretched the audio samples to use the same distribution of the lower class. Maybe you didn't understand anything of what I said, so I tried to illustrate it in very simple few words. Let's say that we have the two classes, the orange one and the blue one. The orange one are the stress samples. The blue ones are the unstressed. As you can see, we have less samples related to stress data. So let's say that we can understand the relationship of the orange samples to understand the audio features distributions that are most important on the orange one. Now let's say, and this is what we did, let's expand those samples by creating more and more of those samples by stretching the files, the audio samples that we already have. And this is indeed what we did. And we created a balanced data that has enough samples of each of the classes. Now, I will try to play here another challenge that we face with. So I hope it will work.
And now in all of the world is strange. And now in all of the world is strange. And now
and I will pause because you heard, by the way, two different examples saying the same word. It was only 5 to 7 seconds. Most of you probably didn't hear any difference of those examples, but I can tell you that we played with quality attributes of each of the recordings that you just heard. We played with the bitrate, we played with the sample rate, we played with audio compression, with some of the properties that might affect those information. Now, even if you didn't hear the differences between those samples, but a network will have problems when it will try to use the same examples as the input to the network. So, and why is that? Due to the fact that most audio approaches today, when they are reading the data, are reading the data in a fixed length of buffer duration. Now, if we will take the properties that we have that might change, they might enter us bias, noises, or maybe something else. We can calculate and take incorrect information within the data. So what we did, we calculated the buffer length, which is updated dynamically related to those properties, related to those compression type, related to those bitrate type. Because there are a lot of properties within the audio recordings that might affect those. And by using those dynamically, we can gain more information. And the last thing is, which audio feature should we use? First of all, I can take the raw representation of the audio samples and enter it to a normal neural network as is. But when we look on previous articles regarding emotion, we saw one of the most big research that was done during COVID-19, a health one, that took and understood that stress is obtained within specific audio features coefficients called MFCCs, only on a specific one. But when we look and expose those MFCCs value, we saw that even within the same sample related in this example for the stress class, we could see, and you can see, by the way, only by the coloring of each and every sample, you can see that they are different. Different, not in a way that one is green and the other one is more greener or a blue one. You can see that they are very different in kind. So it made us think maybe we can use it. So what we did, we looked on the entire samples related to this specific class, by the way, with the stress class, and calculated the difference of the MFCC coefficients and understand the relevant distribution upon them. By using that, we created a new audio features that eventually it was the relevant input that we entered to our network. And it assists us to identify the stress and no stress related interactions. I have 1 minute and I'm going to finish on time. Eventually, we wanted to evaluate ourselves. Unfortunately, I cannot show to you other data except public data. So I will present an evaluation that we did on a public data set related on an emotion detection. So we took a positive and negative emotion detection task, same binary classification, but in this time we use our algorithm and we compare with the most common parameter of the average recall. And we saw that with our new algorithm, we got an improvement of around 12% of the average recall versus the best algorithm that there is today in the market regarding emotion detection, binary classification. I finish. Thank you very much.